Have a nice day, students. Welcome to Conceptual Chemistry. In this section, we are going to discuss the alkaline earth metals, group 2 elements, continuation of S block elements. Let me start with the electronic configuration. Electronic configuration for the group 1 element, we discussed NS1. Here for the group 2 element, it will be NS2. Unlike alkaline metals, the alkaline earth metals also it will be ionic, because when you move down the group, the electropositive character it will be increases, so it will be ionic only. And here the electronic configuration, if you note down, means it will help to understand the general electronic configuration. For the beryllium it will be 2s2, and for the magnesium 3s2, and calcium it will be 4s2, strontium 5s2. And here the barium, the electronic configuration is written in two methods, that means one long method and short method. So short method means we can use the nearest noble gas configuration. For example, barium, the nearest noble gas is xenon. So using that configuration we can write the electronic configuration for the barium like this very shortly. This is a short method. So the radium also, using the radon, nearest noble gas configuration, we can write radon 7s2. Atomic and ionic radii. Atomic and ionic radii, what will happen to the group 2 elements? When we move from left to right, the same shell is there, but protons it will be keep on adding. Here 1 proton means here 2 proton, and here 3 proton. So once the proton increases, the size it will be small. So when you move from left to right, the atomic and ionic radii it will be decreases. So based on this concept, the atomic and ionic radii of alkaline earth metals it will be less compared to the alkali metals. Atomic and ionic radii of the alkaline earth metals it will be less than the alkali metals. That is the reason. So once the atomic size is less, which will be higher? It will have a higher nuclear charge. If the atomic size is less, it will have a higher nuclear charge. If it is have a higher nuclear charge, then it can attract the outermost electron. Once it attracts the outermost electron, the atomic and ionic radii it will be smaller, correspond to the alkali metals. When you move down the group, the same concept. When you move down the group, the shells it will be keep on adding. When the shells adding, the atomic and ionic radii it will be increases. So in this concept, we want to learn two statements. When you move from left to right, atomic and ionic radii decreases. Due to that, the atomic and ionic radii of the alkaline earth metals it is less compared to the alkali metals. And when you move down the group, normally it will be increases. And when here in the screening effort also is that when you move down the group, we will discuss this. Ionization enthalpy. What will happen to the ionization enthalpy? Ionization enthalpy has already said that the amount of energy which is required to remove the outermost electron. So here, when I compare to the alkaline earth metals, the size is small. If the size is small, ionization enthalpy it will be large only. The ionization enthalpy compared to the alkaline metals it will be large. Okay, that is one concept. Then another one. The first ionization enthalpy, when you move down the group, general concept, when you move down the group, the ionization enthalpy it will be decreases. In that there is no doubt. Why the ionization enthalpy decreases when you move down the group? Because when you move down the group, the number of shells it will be keep on adding. As the number of shells adding, the nuclear force of attraction it will be less. When the nuclear force of attraction is less, we can remove the electron very easily. Due to that, the ionization enthalpy when you move down the group it will be decreases. But here we want to remember one more concept: first ionization enthalpy and second ionization enthalpy. What is first ionization enthalpy? For example, we are taking the barium electronic configuration 1s2 2s2 1s2 2s2. So in the second shell 2 electron will be there. So when I try to remove this 1 electron, it is very difficult, because we know the S it will have a more screening effect. The S orbital will have a more screening effect, so it will not remove the electron that much easily. It will not leave the electron that much easily. So it is very difficult to remove that 1 electron. But if I take the alkali metal like lithium, it will be 1s2 and 2s1. Alkali metal lithium it will be 1s2 and 2s1. Here, if it lost this 1 electron, in lithium, if it lost this 1 electron, then it attains the nearest noble gas configuration. But in beryllium, it is not in beryllium. In beryllium, if it lost 1 electron, then what will happen? The electronic configuration it will become like this: 1s2, 2s1 only. It will not attain the nearest noble gas configuration. So due to that reason, the first ionization enthalpy of the alkaline earth metals, it will be higher. The first ionization enthalpy of the alkaline earth metals, it will be higher. The meaning of first ionization enthalpy means the energy which is required to remove the first electron, the outermost first electron, that is called first ionization enthalpy. So in beryllium it will be more. Then one again I am going to try to remove this electron, second electron. I am trying to remove the second electron. This is the first electron we removed, and we spend more energy to remove that. And when I try to remove the second electron, I don't need to spend more energy. The reason, because if it lost this one electron, then it attains the nearest noble gas configuration. Due to that, we no need to spend more energy. We can spend less amount of energy to remove this electron. So the second ionization enthalpy of the alkaline earth metals, it will be less. So this is the concept. So in the first ionization enthalpy, it will be higher compared to the alkali metals, and second ionization enthalpy, it will be smaller. But if we take the lithium 1s2 2s1, by removing this electron we can call that as the first ionization enthalpy. It will be less. But if I try to remove one more electron here in the 1s, it is very difficult, so it will be more. So in alkali metals, second ionization enthalpy is very high, but in alkaline earth metals, second ionization enthalpy, it will be smaller. Hydration enthalpy. What will happen to the hydration enthalpy? The same concept what we discussed in the alkali metals, here also it will be applied. And one more concept we want to know. When I compare the group 1 element and group 2 element, which will be have a small in size. That's we discussed in the starting slide itself. When you move from left to right, the size it will be decreases. So when I compare to group 1, group 2 it will be less. So when group 2, when the size is less, then the hydration enthalpy also it will be greater than the group 1 element. The hydration enthalpy also it will be greater than group 1 element. So the hydration enthalpy, the group 2 element, it will be greater than group 1 element. The reason is the size it will be smaller compared to the alkali metals. So that only they mentioned here. Due to the small size of alkaline earth metals compared to the alkali metal ions, the hydration enthalpy it will be greater. So here they mention the order. Beryllium, it is the smaller in size. Beryllium 2 plus ion, it will be have a higher hydration energy enthalpy compared to the barium. Then physical properties. Physical property, like alkali metals, it will be harder. They are harder than alkali metals. When you take the alkaline earth metals, they are harder than alkali metals, and when they are harder than alkali metals, the melting and boiling point also it will be higher than the corresponding alkali metals, because the size is smaller. When size is smaller, the bond also it will be smaller. As already we discussed, the bond is smaller, it is difficult to break it. So due to that, the melting and boiling point also it will be higher. And when you move on the group, the tendency to lose the electron it is more. So the electropositive character also it will be increases down the group. The electropositive character it will be increases down the group. As the size increases, the electron it will be lost very easily due to the less nuclear force of attraction. Then except beryllium and magnesium, all the other alkali earth metals it will impact color. That means in the flame test we can identify the reason why the beryllium and magnesium not giving the color. Means in beryllium and magnesium the size is small. So if the size is small, it will hold the electron very tightly. When it holds the electron very tightly, when you try to flame it, this electron it will not go to the excited state. It will not excited. Simply it will not excited that much easily, because the nucleus is holding. Due to that reason only, it will not respond in the flame test. Alkaline earth metals it will be a high thermal and electrical conductivity as alkali metals. As it will have a low ionization enthalpy, when you move on the group, the ultrapositive nature it will be increases. So the ultrapositive nature increases when you move on the group from beryllium to barium, because size increases. Strontium, barium, it will impact certain characteristic color. So strontium, if you see, means it will give a crimson red. This we will do in the YouTube channel. In this channel we will do, and I will display it to you. So strontium it will give the crimson red, barium apple green color, and sodium it will be yellow, as already we discussed. Because this elements and all the size it will be more, so the electron can easily excited. When you heat it, it will easily excited to the from ground state to excited state, and it will give the characteristic color. The alkaline earth metals, like those of alkali metals, it will have a high electrical and thermal conductivity. This already discussed. The flame test of calcium, strontium and barium, it will be helpful in the detection of the qualitative analysis. That means when you're trying to do the salt analysis, this flame test will be help you identify whether it is a calcium, strontium and barium. And it is also useful in the flame photometry also. What are the use of flame photometry? It is not given detail in your book, but you want to know the concept. Flame photometry, it is used to identify the concentration, how much concentration the alkaline earth metals it will be there. So to find out the concentration, we are using the flame photometry. How to find the concentration? Here, this is the working principle of the flame photometry. So we have any sample. That means in the sample, the alkaline earth metals is there. So that sample you are taking, and we want to evaporate it. When you evaporate, it will become solid residue. So once solid residue is there, then it evaporates, it will be changed into gas. Then gas atomize, it will be changed into ions. Once it changes into ions, again you are simply heating, then the electron from the ground state will go to the excited state. Then it will come back and it will emit radiation. By that emitted radiation, we can find how much concentration the metal it will be present. So here the structural representation, the sample, the alkaline earth metal sample we want to take like this, and we want to pass to the nebulizer, and here the compressed air we want to pass it to move to the mixed chamber. In the fuel is there, because then only it will burn. So all this sample, when it move, when it go to the flame, it will burn. When it burn, all this thing will happen. When it burn, all this thing will happen. That means in the sample, the metal it will change into solid, and it will be changed into gas, and it will be ions. Once it change into ions, it will go to the excited state and it will emit radiation. That emitted radiation we want to pass through the lens. Once the radiation pass through the lens, we want to pass through the monochromator. Why the monochromator here we are using means, because in the sample it not only contains sodium, it may contain magnesium, calcium, whatever it may be, but I want to find the concentration of sodium. So in this monochromator I want to fix in the wavelength 589 nanometer, like that. In the wavelength we want to fix. So once I fix like that, then the monochromator will absorb only all other radiation. The monochromator will absorb all the other radiation, and it will pass the sodium wavelength alone. So the sodium radiation alone it will pass. So once the emitted radiation, when it pass, it will go and reach the detector. The detector is nothing but photodiode or photoelectric cell, like that you can say. Photodiode, what is the role means, it will convert the light energy into electrical energy. That is the function. So it will convert the emitted electrons which is coming now, it will used to generate the current. Then in that meter it will show the reading. So if the concentration is more, then the meter it will show greater readings. If the concentration is less, then the meter it will show lesser reading. By this way we can find the concentration. So where it will be applicable means, suppose if you go to the higher studies, if you choose in the medicine means, there definitely you will study this. In body fluids, in human body fluids, what is the concentration, that is sodium, potassium, like that. In that case it will be used. And if you choose chemical engineering also, it will be studied in detail, it will be discussed in detail. This is the concept in the flame photometry, students. So one concept you want to remember, flame photometry, it is used to find the concentration of alkaline earth metals. Okay, now we discuss the chemical properties. Alkaline earth metals, when it react to the oxygen, like beryllium and magnesium, it will form an oxide layer. Beryllium and magnesium, it will form the oxide layer. Once the oxide layer form, it will not react. It will be like inert. It will not react. But this reactivity of the oxygen, it will be increases when you move down the group, because size increases and the ions electropositive nature, it will react to the oxygen readily. Then alkaline earth metals, when it react with the halogens, it will form the metallic halides. But beryllium we can't prepare like that. We want to prepare the beryllium by the decomposition of ammonium tetrafluoroberylate. So when you heat this, you will get the beryllium. Reacted towards hydrogen. Alkali metals, when it react to the hydrogen, it produces metal hydride. But beryllium, if you want to prepare means, you want to use the hydrating agent like lithium aluminum hydride in the presence of solvent ether. Then we can prepare the beryllium hydride. The reason is the small in size, that is the only reason. Reacted towards acid. This we know in the lower classes we discussed. Alkaline metals or alkaline earth metals, when it react with the acid, it will form salt. Like this you can put a box MCl and the remaining thing H2 with the liberation of hydrogen gas. Reducing nature. So reducing nature, if you want to say, means you can remember the outermost electronic configuration. This is for the group 1 and this is for the group 2. So group 2, the outermost electronic configuration is 2. So the loss of electron, 2 electron it want to lose to attain the nearest noble gas configuration. But here in the group 1 only 1. So based on this you can say reducing nature which will be more, group 1 or group 2. So group 2 it will be the reducing nature, it will be less compared to the group 1. The reducing power it will be less compared to the alkaline metals, it will be less. The reason is because it want to lose 2 electrons. And beryllium, it will have a less negative value. In the previous class, in the previous section we discussed, if it is more negative value, means the compound it will be stable. If it is less negative value means the compound it will be less stable. Here also, why the beryllium it will have a less negative value means the beryllium, the size is very small. And suppose for chlorine it try to form a bond, what will happen? The chlorine size is very bigger and this atomic size of the beryllium is very small, so it will not lose the electron that much easily. If you lose the electron, then only it will form ion and it will react to the chlorine. Due to that, it will have a less negative value. Then solution liquid ammonia. This is the same concept what we discussed in the alkaline metal, the same thing it will be repeated. Alkaline earth metal also, when it react with the ammonia, it will give the deep blue color due to the paramagnetic nature. Due to the ammoniated electron, it will give you a deep blue. And uses, beryllium it is used in the manufacture of alloys. Copper beryllium alloys are used in the preparation of high strength springs. This you can see in very heavy vehicles. Heavy vehicles you can see like this type of springs. So it is made by the beryllium alloys only. Metallic beryllium is used for making windows of X-ray tubes. And magnesium forms alloys with aluminum, zinc, manganese and tin. The type of magnesium aluminum alloy, it will be light in mass. So it is used in the aircraft construction. In the aircraft construction it will be used. And magnesium powder and the magnesium ribbon, it is used in the flash powders and bulbs and incendiary bombs. Incendiary bomb means when you try to throw it, it will burn. It will create the fire. Once it creates the fire, suppose if there is a very big fuel tank is there. If you throw this incendiary bombs, then it create fire. If it create fire, then the fuel it will burn very effectively and it causes severe damages. So mostly in militaries it will be used. And in signals also, to produce signals also they will use this incendiary bombs. Suppose for rescue somebody is coming, they left out in some place, so they find out, they identify some helicopters, it is flying, and to divert the to focus the direction of the helicopter, they will explode this incendiary bombs. It will create the fire and smoke. Due to that, it will be act as a signals. Then magnesium hydroxide we discussed in the lower class in the grade 10. It is antacid. So it is coming from the alkaline earth metals only. Then magnesium carbonate, it is used as ingredient in the toothpaste also. And calcium, it is used in the extraction of metals. So extraction of metals from oxide. So if iron oxide is there, in that case if you are adding calcium it will be more reactive than iron, so it will form calcium oxide. So extraction of metals, wherever the carbon is not reducing, in that place we can use the calcium. So in the extraction purpose of the metals, the calcium is used. And calcium and barium, it will be react to the oxygen readily because the size is very large. As we discussed, the reactivity with the oxygen it will be increased when you move down the group. So due to this nature, it is used to prepare the vacuum tubes. Suppose there is one vessel. In that vessel, I want to maintain vacuum. So if some air is there. If I keep calcium or barium, what will happen means it will react with the oxygen and it will form calcium oxide and barium oxide. So whatever the oxygen which is present there, it will be taken. So vacuum it will be created. So to remove air from the vacuum tubes, this calcium and barium it will be used. And radium salts. Radium salts are used in the radiotherapy for the treatment of cancer. That means to kill the dead cells it is used. With this I will finish this section, students. In the next section we will discuss the characteristics of alkaline earth metals. Like, share and subscribe. Thanks for watching.